quickly. What are we going to be doing? Conditional execution one more time. What are some of the goals and objectives for today? We want to be able to work with Boolean expressions. So we talked about different data types. Today we'll talk about the bool data type or bool class. And we'll also look at logical operators. We looked at operators last time as well. We talked about arithmetic operators, plus, minus, multiplication, and so on. We also talked about assignment operators, assigning values to variables. Today we'll talk about logical operators, okay? Get some logic in there because we definitely need that in order for us to execute programs conditionally. So that will lead us into conditional executions. And it's always a good idea to be able to catch some errors. What you submitted so far, there might be, we're assuming that everybody is going to be working with stuff like a normal human being, not crazy people like myself that just want to break stuff. So we want to be able to catch exceptions gracefully and not to break our program or cause some errors that users might not find appealing. So at the end of the day, we'll learn how to use that conditional logic to create decision-driven programs. What if we wanted to differentiate singular and plural and so on and so forth? And then we'll also use exceptions output for debugging and also affecting the logic when exceptions happen. Exceptions are more or less like errors, right? So let's get started. Boolean expressions, what are they? They're pretty much any expression that evaluates to either a true or a false, okay? So are you a boy, true or false, okay? Is 5 equal to 5? As you can see in this case, it's very true. Is 5 equal to 6? No, so it's very false. Remember, that true is capital T and false is capital F, okay? The case is very important. And we talked about numbers and letters, right? Strings and integers, for instance, or floats. So we're able to tell what data type when we use the type function. So if you use type and you put in the value of true in there, it will tell you that it's a bool data type or it's a bool class. So that's a way that you can always identify. If the true is in quotes, then it's a string. So true in quotes is a string. True without any quotes is not a string. It is a bool. The same for false. Does that sound good to everyone?
Yeah.
Awesome. So the next thing then we want to talk about is the equality operator. This is definitely different from the assignment operator. In Python and most other programming languages, you use two equal signs to mean equality. In this case, 5 is equal to 5. If you use just one equal sign, it will mean 5 on the right-hand side is assigned to 5 on the left-hand side, and that will give you an error. So when you're writing an expression, you want to make sure you use the double equality sign. That's a very common error that you get, so we want to avoid those common errors. And some other operators, in this case, comparison operators. I talked about logical operators, we'll talk in the next slide, but there's also comparison operators to compare the left-hand side and the right-hand side. Again, they are not assignment operators. We can use two equality signs to say the left hand is equal to the right hand, or we can use an exclamation mark and an equality sign to say it is not equal to. There are a bunch of other examples, greater than, less than, greater than or equal to, less than or equal to. Those are all comparison operators. You're comparing left-hand side. Is this left-hand side for you guys? Yes. Left-hand side and right-hand side together, okay? And based on that comparison, the result is either true or false, okay? So based on that comparison, it gives you a true or false response. And we want to also point out that there is nothing like equal to, less than. That's not the right way of writing it. The order of writing it is very important. So as you can see here, greater than or equal to, you don't say equal to or greater than. Less than or equal to, you don't say equal to. Okay? So just make sure you identify those. So a few things we've talked about so far: Boolean expressions, true or false, the particular class or data type, the operator, which is a comparison operator, not an assignment operator, and some common errors that we can avoid. So we'll write those down in a little bit. Now, logical operators, those are another type of operators, okay? They have the same semantic meaning as in English language, like the and. You say, I am a boy and I am African, okay? So those two are true. If both conditions are met, then it's true. Anything else, it's false. If I say I am a girl and I'm African, obviously I'm not a girl, I'm a boy. So that is false. But if I use the or logical operator, at least one condition has to be met for it to be true. If one condition is met, then it's true. Otherwise, it's false. So for instance, I am either a boy or I am black. Both of them are true, so it is true. But if I said I am either a girl or I am white, both of them are false, so that will equate to false. All right. And a third option for logical operators is not. It just negates whatever value it was. So you go ahead and evaluate whatever expression is given to you before you negate it. And there's a nice table out here to point out a few things for you. As you can see, if A is false, that means if the first expression A is false, or it's called in this case sub-expression, and B is false, then A and B will give you false. A or B will also give you false. But if either A or B is true and the other one is false, then if you're using an AND logical operator, both of them will be false. But if you're using an OR logical operator, both of them will be true because at least one has to be true. But now if you want to negate A, which is in the first column, all you have to do is reverse this value to give you the value on there. All right. So it's always beneficial to use logical operators when we want to test sub-expressions, left and right expression, or multiple expressions in that case, or if we want to look at multiple conditions, which we're going to see. These are all things that we need to talk about because they are the ones that drive us into getting into conditional execution. All right. What questions do you guys have? Then, no questions so far. It's as clear as mud.
I don't understand the negate, the not expression.
Okay. Very good, very good. You do not understand the negation. Let me try and do an example for us. Examples are always good. I'm going to go into our Python. So yeah, Anaconda in the cloud, and probably start a new notebook on here. Let's create a new notebook and call that day 3. Yep, I'm going to select that. All right. Let's rename this day 3. And if we take an example, let's try the example that we had. 5 is equal to 5. Oops, you cannot see. I don't know if you guys can see. Let me make that bigger. If we use this and execute that, it tells us it's true. But if we say not 5 is equal to 5, what would we get in this case?
False.
False, because it's going to give us the reverse of whatever we had in the first place. Now we get an error. Why do we get an error? Because not is not defined. The way I've written it, it means this is a function. So if I want to write it that way, let's put it that way. Now we're saying not 5 is that. That should also still give you an error message because we're trying to get a negated value. So let's say A is equal to 5 and B is equal to 6. C is also equal to 5. Now we can go ahead and execute that. Nothing is going to happen. But we can now compare these. A is equal to B. That should give us false. Let me go ahead and if we execute that, we should have false. But if we say A is the same as C, this should give us true. Spell correctly. So that gives us true. But if we wanted to negate, say A is not the same as B, oopsie, not B, then we're saying that this is not that. So it should give us true, right? Let's execute that if I can try it. No, it doesn't. No. What we're using earlier, I should not be using a capital letter in here. I should be using a lowercase, as you can see. So that lowercase is what the issue was. I've been preaching to you that case sensitivity is important, and I fell for my own trap. So does that make sense? And does that clarify your question earlier?
Yes.
Awesome. So as you can see, it's useful to also use multiple IDEs or multiple tools. Otherwise, I will not be able to tell that not should be lowercase, definitely lowercase. All right. Very, very good question. Please don't hesitate to stop me if you have any questions. So we can also use that not, say not A, execute that, it says false. But why would it say false if A is 5? Does anybody know why that is?
I don't think I got the question.
So in this case, I said not A, and it says false. But if I type in A and execute that, A is 5. So I'm saying that not 5 is equal to false. And in this case, we're just saying 5 is an integer, right? Because if you check the type of 5, it will tell you it is an integer. So the point I'm trying to make here is there are only 2 numbers that are always going to be false, 0 and none. Every other number is true. So if you say not true is equal to false. If I were to say not 0, what answer would I get? So let me go ahead and make a comment here. 0 is false. And also another comment on, oops, can't spell, on is false. So these are the 2 things that you want to always remember, oops, that are false, 0 and none. So if I say not 0, I should have true, okay? So for some reason, Boolean is always going to say any number that's a 0 should evaluate to false. Any number that's none should evaluate to false. Every other number is true, okay? So if you're doing a computation and you're going to use them to decide a Boolean value, be very careful with integers. Integers will always evaluate to true, except it is a 0 or a none value. None is an unknown value, absence of a value. Sounds good to everyone? So it's going to make more sense once we get to the next part. So let me jump again back into where we were talking about logical operators. Okay, the and, when you have both sub expressions, at least one of them has to be false and then it's false. Both of them must be true for it to be true in case of an and operator. But for an or operator, at least one of them has to be true for it to be true. But if you're going to negate the value, it's just going to change it from whatever value it was in the first place. If A is false and B is true, then the opposite of false would be true, the opposite of true would be false. Sounds good?